I am in the completing the square.
Okay, have you done the square root stuff yet?
The nonlinear functions?
Yes, sir.
Yes, I completed that a long time ago.
Okay. Lakin, where are you?
I actually got ahead today because tonight I'm going to spend the night with one of my friends. So I already did like my unit test review, and then I think I finished my unit test. I think I made like a 85 on it or something like that. I think I finished it today.
Was it quadratics or nonlinears?
Let me go and look really quick. I think I've taken both of those tests. Okay, wait. Quadratic. Yeah, on the quadratic test, I made an 88, and on the nonlinear functions test, I made an 86.
Okay, cool. Jacob, where are you? You have to unmute yourself because I can't hear you otherwise.
Let me go see.
And same thing, Miss Roney, where are you? Since Jacob is looking as well.
I'm on basic probability,
Okay.
vocabulary.
All right. So I think everyone. So Jacob, did you find out where you're at?
I'm logging in right now.
All right. From what I remember, I think you finished I think I got you down for quadratics. You're either done or almost near done with quadratics. And I don't check nonlinears for you. Well, if I did, I don't remember checking nonlinears for you. So
I'm on I'm finna be on the test on quadratic functions.
have you done
on
nonlinears yet?
On nonlinear, I'm on, let me see. On nonlinear, I'm on the instructions. Finna be on the test.
All right. So everyone's either done with quadratics or nearing done, and everyone's almost done with nonlinears as well. Does anyone have any questions about any of those two units? I think we left off class-wise, we left off in nonlinears, and quadratics is what we would have covered in class had we not gone to, for the virus. So that leaves statistics. Now you've got basically a week and a half to finish statistics. So remember, everything is due not this Sunday, but next Sunday. So whatever you get to me by next Sunday, I'll put the grades in. And once you get done with this unit, that's it. You're done for Algebra 1 for the year. Whatever you don't turn it in, I have to put in zeros. So you don't want like 5 zeros in your grade book because that's going to kill your grade. Okay, so
I have a question about that.
Sure.
Okay, yesterday, remember when you said something about like my 0 at the beginning of 9 weeks? And you said if I get all my blank, like all the ones with the blank before next Sunday, that you would like swap it out. Like, what are you going to swap it out with? Like one of the grades from the computer or just?
Yeah, so since quadratics covers the same thing that you had a test on, I'm going to take the grade that you made in quadratics and replace your 0 with that grade as well.
Okay, got it.
Yeah, all right. And I'm still honoring that. If you finish everything by next Sunday, then that's what I'm going to do. All right.
Okay, yes, sir.
Okay. So let's start off with statistics. Now, the thing is, for some people, either statistics is going to be really easy or it's going to be really hard. It's a lot of word problems and a lot of conceptualization. And I'm going to be honest with you, sometimes when I look at statistics, I sort of have to take a minute and like reread the problem to understand what they're actually asking me. And it's difficult for me at times. And of all the mathematics out there, statistics is my least favorite, if you will. All right. I do it and I still work with it, but it's not my favorite thing to do. So some people will like this and you'll just blaze through it. Others of you will sort of struggle with it. And it's just trying to understand what the question is asking you and applying the right formulas. Okay. So let's talk about what we covered last class. So we said probability. Let me share the screen because you can't see my screen. Hold on. Okay, so P of X stands for probability. And when you calculate probability, you'll get something less than 1, some value less than 1. Okay, so it'll be like 0.65 or 0.22 or whatever. Okay, and if you multiply that probability times 100, you'll get the percentage probability. So, you know, like if you see a movie or something like that, when they talk about stuff, they'll say you have a 40% chance of this occurring, or there's a 15% chance of this happening, or 3% chance of this happening. That's statistics, okay? So if they say something has a 15% probability, what they're saying is that the probability is just 0.15, okay? So know the relationship between the decimal and the percentage. Now, to calculate probability of an event, it's the total number of times the event can occur over what we call the sample space. Okay, the sample space. Now, let me give you an example of this. So let's say we have a spinner. Okay, and it's divided equally into, say, 8 pieces. Okay. Now, you have a spinner, and I want to ask you, what is the probability of it landing on any one of these numbers? Okay, so let's say, what's the probability of the spinner landing on 7? Okay, so how many times does 7 occur on the wheel? Well, it only occurs once over the total number of events that occur, which is 8. So the probability of you landing on a 7 is 1/8, or if you do the decimal equivalent, I think it's 0.125. Okay. So to calculate the probability, it's the number of times that event occurs over the total number of events. Okay. So knowing how to calculate the sample space is pretty important. Okay, sometimes it's easy, like, okay, how many different outcomes can you have in this event? Well, you can have 8, so you don't have to do any calculations. But sometimes calculating the sample space can get difficult. And that's where the multiplication principle of probability or of counting comes into play. So say, for example, I have a situation like this. Say, for example, I have 2 events. Okay. I have a event that can have 7 outcomes, and then I have another event that I can do that has 5 outcomes. What are the total number of arrangements of all events? And the multiplication principle of probability says that I can multiply the total number of outcomes of both events, and that tells me the total number of outcomes or arrangements. So let me give you an example of this. Hold on one second. Let me turn off my Alexa thing. Hold on. Okay, so let's say, for example, you go to an ice cream shop and you're going to choose a ice cream flavor, and then you're going to choose a topping. Okay, and in this ice cream shop, they have 4 flavors of ice cream. So say they have chocolate, vanilla, strawberry, and I don't know, let's see, pistachio, or let's say butter pecan. And they have 3 choices of toppings. So they have a choice of, say, fruit, sprinkles, or nuts. Okay.
My fault. I lagged out.
So every one of these, no problem, Jacob. Every one of these ice cream flavors can have any one of these 3 toppings. So the question is, how many different arrangements can I have? Well, I can have chocolate with fruit, chocolate with sprinkles, or chocolate with nuts. I can have vanilla with fruit, vanilla with sprinkles, vanilla with nuts, strawberry with fruit, strawberry with sprinkles, strawberry with nuts, butter pecan with fruit, butter pecan with sprinkles, and butter pecan with nuts. So we can have chocolate fruit, chocolate sprinkles, chocolate nuts, vanilla fruit, vanilla sprinkles, vanilla nuts, strawberry fruit, strawberry sprinkles, strawberry nuts, butter pecan fruit, butter pecan sprinkles, butter pecan nuts. So how many total arrangements can I have? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 total, okay? So my sample space here is 12. If my sample space is the total number of arrangements between the flavors and the toppings, my sample space is 12 here. And we could have done this tree diagram, that's what I did. Or we could say, okay, event 1, which is my choice of flavors, is 4. Event 2 is my choice of toppings, which is 3. So the fundamental multiplication principle says I can multiply the number of events or the number of possibilities of event 1 times the number of possibilities of event 2. And that's, I can get the same thing. And I can bypass doing this whole like tree thing, okay? And that is known as the fundamental multiplication principle, okay? Does everyone understand that? Okay, so let's take, for example, 2 dice, okay? Each dice has 6 sides, okay? Each one has a number, 1 through 6. And how many different combinations can I get when I roll 2 dice? So event 1 is the number of outcomes if I roll 1 dice. Event 2 is the number of outcomes if I roll the second dice. So there's a total of 6 times 6, which is 36 different combinations. Okay. Now, let's say, for example, I have, how many of y'all have phones? I know every one of y'all have phones, right? So
Right.
on the, when this phone freezes, you can put in a passcode, right? They ask you to put in a passcode. Now they ask you to put use a 6-digit passcode. However, you can elect to say, okay, I just want to use I just want my passcode to be 4 digits each, okay? Now let's look at that. So I'm gonna put in a passcode and it's gonna have 4 digits. Each one of those digits can be either 0 through 9. Each one of those digits can be 0 through 9. And I'm going to have 4 digits. So how many total combinations can I have? Well, let's do it. Event 1 is the choice of the first digit of your passcode. Event 2 would be the choice of your second digit. Event 3 would be the choice of your third digit. And event 4 would be the choice of your fourth digit. So from 0 to 9, that's 10 digits, okay? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 digits. Event 2, also 10 digits. 3, 10 digits, 4, 10 digits. So you can multiply 10 times 10 times 10 times 10, which is 10 to the 4th power, which equals 10,000 different possibilities for the code, all right? Which is a lot, but not infinite, right? Okay, that's why they want you to do 6 numbers. Because if you do 6, each one could be 0 to 9, then the total combination is 10 to the 6. So 1 with 6 zeros. So 1 million possibilities of choices if your passcode was 6 digits. So if somebody's trying to hack into your phone or break into your phone, if you have a passcode of only 4 digits, they only have 10,000 possibilities to check. Whereas if they have a possibility of, if they have to guess 6 digits, they have to guess 1 million different possibilities, which may or may not be possible. Okay.
I don't think that matter, Mr. D. Everybody be putting 0, 0, 0.
Well, you're not supposed to, but you know, that's what I'm saying. Okay. All right. Now, let's talk about 2 things in statistics: and versus or. Okay. So these are called compound probabilities. Okay. Compound probabilities. When you see and in statistics, think multiplication. And when you see or in statistics, think addition. Okay. So let's say, for example, I roll a dice. So my outcomes are 1, 2, 3, 4, 5, and 6. Okay. And the question is, what's the probability of me rolling a 4? Okay. Well, how many times does 4 occur on a dice? 1. So I have a 1 of 6 probability of rolling a 4. Okay. Now, say instead, I don't want to know what's my probability of rolling a 4, but what if I want to say, what is my probability of rolling a 4 or an even number? Okay. So again, we talked about the probability of rolling a 4 was 6. And the probability of rolling an even number is, well, how many even numbers are on the dice? 1, 2, 3. So the probability of rolling an even number is 3 out of 6. So the probability of rolling a 4 or an even number would be 1/6 plus 3/6, which is 4/6, 2/3, which is 67%. Okay. Now, this is how we do compound probability. So when you say or, you have to think of addition, okay? So now let me ask this another way. What's the probability of me rolling an even number and the even number is divisible by 4? Okay. So the probability of me rolling an even number and divisible by 4. So the probability of me rolling an even number is 1/2. And so it's multiplication divisible by 4. Well, how many of these numbers is divisible by 4? Well, one of them. So the probability of me rolling a even number divisible by 4 is 1/12. Okay. So take home point, if you see or in math, in probability problems, think addition. Okay. Any questions? All right. Let's have you guys do a problem type. So let's look at this problem right here, okay? Many colleges and universities use computer-assisted testing. Suppose the screening test is to consist of 5 questions, okay? And a computer stores 5 comparable questions for the first test question, 8 for the second, 6 for the third, 5 for the fourth, and 10 for the fifth. So if you don't understand what that question is saying, go back and reread it, okay? So you're making a test with 5 questions, right? And this is actually how I create your test in a way. So in the computer, for question 1, the computer has an option of choosing 5 questions. For question 2, the computer has an option of choosing 8. Question 3, 6, question 4, 5, and question 5, they have 10 choices. So question is, how many different combinations or how many different arrangements can this computer create? All right. So the first thing is you have to identify the number of events. Okay. So in this question, each event would be each question. So event 1 would be question 1. Event 2 would be question 2. Dot, 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 all the way to question 5. So event 5 would be question 5. So how many different options do I have for event 1? Well, I have 5. Event 2, I have 8. Event 3, I have 6. Event 4, I have 5. And the last question, question 5, I have 10 options. So what is the total number of combinations that I can make? Well, I would just multiply every one of these numbers. 5 times 8 times 6 times 5 times 10. And if you put this in your calculator, because I can't do this in my brain, I get 12,000. So there's 12,000 different options for tests I can get, okay? Now, let's look at this problem type right here. How many 3-letter code words are possible using the first 8 letters of the alphabet? Okay. So I want to make a code with 3 letters. So each event would be the choice of each letter. Now, this question is broken up into 3 different sub-questions. So sub-question A says, what would be the number of arrangements or combinations that I can get if each letter cannot be repeated? I mean, if each letter can be repeated. Oh, no, sorry, cannot be repeated. So think about it this way. I'm making a password with 3 letters, and I don't want my letters repeated. So once I pick an A, none of the other 2 letters can be A, okay? Or if I pick a C, none of the other 2 letters can be C. So how many options do I have for the first choice? Well, if I have the entire alphabet, that means I have 26 options for the first letter, A through Z. There's 26 letters in the alphabet. Now, event 2 is my choice of the second letter. Well, the way I look at it is say this way, okay? Well, I've already picked one letter from the first letter, okay? So I can't use that letter again. So how many options do I have left if I haven't picked one letter from the alphabet? Well, it would be 26 minus 1, which is 25. Okay, because I already picked one letter, so I can't use that letter anymore. Now, in the same argument, the choice for event 3 would be 24, because now I've used 2 letters, and now I only have 24 more options left. So the total number of passwords I can generate would be 26 times 25 times 24, which gives me 15,600 choices for the password, just using 3 letters. Okay. Now, let's talk about this next concept with statistics called factorial. Okay. In mathematics, we have this notation that you may have seen on your calculator if you have like a pretty advanced scientific calculator, and it's like an exclamation point. Now, it does not mean when if I have five exclamation point, I'm not saying 5 like that. This is an operation. It's called factorial. Okay, so this is the factorial symbol, and it's basically an exclamation point. And what it says is when you have a number factorial, what you're going to be doing is taking that number and multiplying it by every other number smaller than that. So 5 factorial will be 5 times 4 times 3 times 2 times 1. So if you do the math, 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120. 120 times 1 is 120. So when you have a number with a factorial, what you're going to be doing is taking that number and multiplying it by every other integer smaller than that. Okay. So 5 factorial is 5 times 4 times 3 times 2 times 1. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1, and so on and so forth. Okay. Now, couple of identities with factorials. Okay. Now, don't worry about the n if the n is confusing you. So I'm going to show you examples of this. So we talked about the first criteria. So what is a factorial? It's the number times every other integer that comes smaller than that, right? All the way up to 1. The next thing is 0 factorial. 0 factorial is 1. Okay. 0 factorial is 1. Now that doesn't make sense because you'd say, well, 0 factorial means what? Well, there is a proof for it, and if you'd like to know how we got that, just let me know and I'll send you the proof. It's pretty cool if you think about it. Now, the next thing, which is pretty important, is that I can rewrite 5 factorial as 5 times 4 times 3 times 2 times 1, or I can write it as 5 times 4 factorial. Okay. Because remember what 4 factorial is. 4 factorial means 4 times 3 times 2 times 1. Okay. So 5 factorial is 5 times 4 times every number before 4, so 4 factorial. In the same way, I can write 7 factorial as 7 times 6 factorial. I can also do this. I can write it as, say, 7 factorial. I can also write it as 7 times 6 times 5 factorial. Okay. And factorials are really big numbers, and that's why we write it this way. Any questions about what is a factorial and how do we calculate it? All right.
Yeah, why would in the example down there, why would 0 be 1?
Okay, so this comes out to what is a factorial, okay? So how to say this? 5 factorial is 120, right? And 4 factorial is basically 5 factorial divided by 5. Okay. So whenever you do a factorial, you're just going one less. Okay. So 3 factorial is 3 factorial is basically, can be rewritten as 4 factorial divided by 4 2 factorial can be rewritten as 3 factorial divided by 3, okay? And so on and so forth. So how can I write 0 factorial? Well, it would be 1 factorial divided by 1. Well, 1 factorial is just 1. 1 divided by 1 is 1.
Okay, I get it.
Okay. Okay. So let's compute some of these. So I already did 5 factorial. It was 5 times 4 times 3 times 2 times 1, which is 120. Now, 7 factorial over 6 factorial. Well, 7 is factorial can be written as 7 times 6 factorial over 6 factorial. Now remember, factorials are a type of multiplication. So because it's a multiplication, I can remove 6 factorials from both the numerator and denominator. So that just leaves me 7. How about 8 factorial over 5 factorial? Well, the way I would do this is say 8 factorial is 8 times 9 times 8 times 8, sorry, I can't do math. 8 times 7 times 6 times 5 factorial over 5 factorial, okay? The 5 factorials cancel, and that gives me 8 times 7 times 6. And 8 times 7 times 6, if we do the math, would give me what? 336. Okay. Now, 52 factorial over 5 factorial, 47 factorial. Well, 52 factorial can be rewritten as 52 times 51 times 50 times 49 times 48 times 47 factorial over 5 factorial, 47 factorial. The 47 factorials cancel, so that's 52 times 51 times 50 times 49 times 48 divided by 5 factorial. And if we do the math, we get 2,598, I mean 2,598,960. Okay. And that's factorial math. Okay. Any questions on this?
So, Mr. D, when like we have 52 and we gotta like do the thing, when we find a number that is on the equation, we gotta stop, or
Yeah.
when do we stop? Oh, okay.
So the way we do it is, if you look at it, right? If you look at this problem, 52 factorial in the numerator, and I have 47 factorial in the denominator. So the way I do it is I rewrite 52 as 52 times 51 times 50 times 49. I keep going until I get to the same thing in the denominator. So I can go all the way up to 47 factorial. And that will, I can either go to either 5 factorial, so I can go from 52, say 52 times 51 times 50 times 49 times 48 times 47, all the way until I get to 5 factorial. But that's going to be a lot of digits. Or I can go to just 47 factorial, which I did. And once I did that, these canceled. And so that left me a string of these numbers in the top divided by 5 factorial. And we calculated 5 factorial to be 120. So basically it'll be all of these numbers divided by 120.
Okay.
Yeah. Any questions? Okay, so let's have you guys do A, B, C, D, and E. A, B, C, D, and E. Okay, did everyone get these answers? Is there any answer that you did not get or cannot understand how we got it? So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, blah, 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 blah. So I can rewrite 6 factorial 6 times 5 factorial, and we know 5 factorial equals 120, and 120 times 6 gave me 720. 10 factorial over 9 factorial is basically 10 times 9 factorial over 9 factorial. They cancel, that just leaves me 10. Same thing with 10 factorial over 7 factorial. So I cancel out the 7 factorials and basically multiply 10 times 9 times 8, which gives me 720. 5 factorial over 0 factorial 3 factorial is 5 times 4 over 0 factorial, which is 1. So that's just 20. And 1140, we did the same way. Okay. Any questions about factorial math? So the question is, why are we learning factorial math? Well, tomorrow we're going to be talking about these things called permutations and combinations, and they use factorials in their calculations. So you need to know how to work with factorials to be able to do a permutation or a combination. Okay. And we're still learning how to calculate the sample size, the big number on the denominator of a probability. So we need to know how many options do we have before we can say, okay, the probability of this one option occurring is this. Any questions? Everyone good? All right, so if there's no more questions, I will see you guys tomorrow.
See you, Mr. D.
See ya.
See you, Mr. D.
Thanks, Mr. D.
You're welcome.
Have a good day, Mr. D.
To you as well.